Okay, Bella, so we're going to be looking at more examples of compound inequalities today, or what are often referred to as and/or statements. And we're going to look at some trickier examples. I just want to go over two of them right now with you so you can sort of take some notes and get the hang of this. It does take practice, so don't feel bad if you're not grasping this right away. It comes with time. We'll start with this one here. It says solve graph and find the solution set. So we have two inequalities. Negative 2m plus 7 is less than or equal to 13, and 5m plus 12 is greater than 37. So we need to find where these solutions overlap. We want to find solutions for m that satisfy both inequalities. Just satisfying one isn't going to be enough. We need to find out where all the solutions lie. Okay, so the first thing we do is we just solve it. Now this is the easy part, right? Because this is just like solving a two-step equation. So I would subtract 7 here. I'd get negative 2m is less than or equal to 6. And then I divide both sides by negative 2, and I get m is greater than or equal to negative 3. Now over here, I subtract 12. And that's going to give us 5m is greater than 25. So this one just simply solves to m is greater than 5. So here we go. We have our solutions, but we still want to simplify this a little bit because we're saying that m is greater than or equal to negative 3, and at the same time, it also has to be greater than 5. So really, we only need one of these statements because one is going to include the other. Now you can think about this before we graph it. Can you just think about solutions to these? Which one of these statements will contain all of the solutions to the other statement? One of them will. And if you're a little unsure, we can graph it because this will give you a nice visual to tell. So let's start with m is greater than or equal to negative 3. Here's negative 3. We're going to do a closed circle, and I'm going to shade to the right. Now I'll use a different color for the other one. M is greater than 5. Okay, so here's 5. Open circle this time, and we shade to the right. And now all you have to do is look and see where the inequalities overlap. For example, I wouldn't want to use a solution like 2, right? If I say m can be 2, well, that satisfies this inequality. Positive 2 is greater than or equal to negative 3. However, it's not a solution to both of the inequalities. It's not a solution. It's not part of our solution set because it doesn't satisfy this statement. 2 is not greater than 5. However, if you look here where our graphs overlap, solutions like 7, 8, and 9. Let's just take 7, for example. Let's test it. Is 7 greater than or equal to negative 3? Sure is. Is 7 greater than 5? Yes. So the real solution is just m is greater than 5. Our answer to this problem is m is greater than 5. That's all we need to say because it includes all the solutions to this one. All right, let's do one more that's similar. Okay, this time, x is less than or equal to 9, and 2 plus 4x is less than 10. Now this is nice because this is already solved for us, so we'll just leave that alone for right now. And first we'll solve this. So I'll subtract 2, and I'm going to get 4x is less than 8, which is just going to give us x is less than 2. So we have x is less than or equal to 9, and, remember, emphasis on the word and x is less than 2. So which of these is the real solution? Which of these solutions here is going to satisfy both? And if you can already tell, great. If not, we'll just throw the graphs up here. Okay, less than or equal to 9. All right, so I'll do different colors here. We'll make this one blue. X is less than or equal to 9. Here it is. X is less than or equal to 9. And we'll make this one red again. X is less than 2. Here's 2. Less than 2, shading left. Okay, now you can very clearly see that here's the overlap. Numbers like 5 and 6 will be solutions to this inequality, but not solutions to this inequality. So the answer we want is this overlapping region, which is simply x is less than 2. So that's what I mean by interpreting our solutions. Getting here is not going to be difficult for you. You're really good at solving these and getting the answers. It's just understanding which of them is the real solution. Okay, that's what we're going to be working on today. More practice later. See ya.